we'll get started. So the next chapter we are supposed to see is. So those who are online, am I audible?
Yes, sir.
Yes, sir.
Okay. Listen. அது இதுல தான் இருக்கும் அடிஷனல் இருக்காது வாய்ஸ் ஒன் டெக்ஸ்ட் சொல்லி கொடுத்தாங்க டீச்சர் டேட் ஆஃப் we'll start with this remaining data. Listen. So next topic we'll see is mechanical properties of fluids. So here again, when I discuss about the mechanical properties, we are going to discuss about the dynamic properties that is going to get exhibited on the materials, right? So we are going to see the dynamic features like force, pressure, and all those things, which are getting exhibited on the material. Now, now, when I say fluids, what comes to our mind? Basically, liquids and gases. So when you talk about fluids in this chapter, we will mainly concentrate on the physical properties of materials that are liquids and gases in nature. Right? So why are they called fluids? Because fluid is a substance that can flow. Right? So liquids and gases that can flow, liquids and gases have the ability to flow, hence they are called as fluids, right? So this is the main feature that distinguishes whom liquids and gases from that of solids in a basic way. So they're passing a statement like this: fluids are everywhere around us. What does that mean? Naturally, right? So we have air surrounding us. So fluids are present everywhere, and see all these points as I mentioned. Nothing you may not write it. Okay. So Earth has an envelope of air, and 2/3 of its surface that is covered with water. Right. Okay, I don't want to go into all these details. So the main context of this chapter is we need to understand the behavior of the properties of fluids for some real-time applications. Like, where are we going to use them as a question? If water is flowing, right? So when water is flowing, I can use the word pressure. Say you take some water and drop it on your hand. When it comes and hits your hand, you will be able to sense something. And why is it happening? Because the particles are exerting a force on your hand. And if you're able to calculate the total force and divide it with the area, you can say that parameter as a pressure. That is okay. But what is the benefit I'm going to have out of this equation? Right. So the main point or features that we are going to study about is like what happens when there is a pressure difference existing between different points of a liquid. So though we say fluids are liquids and gases, in this chapter we'll mainly concentrate only on liquids. We'll not concentrate on gases. Gases comes under the thermodynamic properties. Okay. So there are not much of mechanical properties that we are going to study about gas. So coming back to the point, what I'm trying to say is we'll need to calculate or understand what is pressure and how will pressure difference make the liquid flow. If there is a pressure difference existing along the horizontal direction, what will happen to it? Will it get compressed or is it going to be in the same state or something of all these sorts? Okay. So for that, we need to understand certain properties, right? So what are the properties that we will see is mainly when you talk about a solid, the first thing that comes to my mind, which is fixed, is volume. right? So except you speak about the mechanical properties of solid, when you apply pressure, there is a change in dimension. But if you see, the change in dimension is on a microscopic. Hence, on an ideal level, what can we consider? We can say that the volume is constant. Whereas liquid and gas depends on the concept of pressure. So you have the option to compress. So liquids and gases have a special property called as compressibility associated. Remember what is compressibility? What is it? Reciprocal of bulk modulus, right? So you have a feature called as compressibility, right? So when we talk about fixed volume of solid or liquid, we mean its volume under atmospheric pressure. That is another point. Second is the difference between gases and solids or liquids is that for solids or liquids, the change in volume due to the change of external pressure is rather small. Whereas for a gas, it is going to be very big. Even for a liquid, what will happen, though it does not have a volume of its own, but it will take the shape of a container. But at the same time, when you try to compress it, its compressibility is going to be slightly on a lesser scale compared to that of gases. Okay. So that's what they're saying. In other words, solids and liquids have much lower compressibility as compared to that solids. And shear stress can change the shape of the solid, keeping its volume fixed. You know what is shear stress? The tangential stress. Whereas with respect to a liquid, it cannot withstand. Right? So the key property of fluids is that they offer very little resistance to the shear stress. Means when you apply the stress, it's not about the change in shape that is going to take place. Start flowing. Right. Next is the shearing stress of fluids is about million times smaller than that of solids. What? Because what does the shear stress mainly do? See, whenever you talk about stress, stress is going to impact strain. That is what we need. So what is strain talking about? Changing the dimensions. Right. When that is going to be the scenario, here what will happen is when you apply the liquid, so for example, if you take the surface of the liquid, you're just going to push it like this. It will start moving faster. So if you take that to be the change in dimension, then you can say that the shear stress is going to be very less. Means even for lesser force, you can see a larger impact. That is the thing. Okay. So anyway, these are all only the introduction. So first basic point that we need to understand is what is pressure? Right. So what is basically a pressure? Right? Can you tell me what is pressure? If I take a surface,
Force by
and-
area, sir.
but you add small correction, pressure you write it as force divided by area. Right. So if you are able to apply force on a particular area and you take the ratio of both those parameters, it is going to be called as pressure. But here the correction is force is a vector quantity. Right. Area is a scalar quantity. So when you divide a vector with a scalar, what are you supposed to get? You will get a vector quantity, but pressure is not a vector quantity. It is scalar. And why is it happening? Because the force that you are trying to define with respect to pressure is always perpendicular force. It is always the perpendicular force per unit area that you need to take into consideration. And the perpendicular force is called as thrust per unit. Right? So if you're able to define the parameter thrust per unit area, where thrust is what? The perpendicular force or the perpendicular component of the force. Right? Then you call that parameter as pressure. And how is pressure measured as? It is measured as measured in terms of Newton per meter square, or this Newton per meter square is also called as Pascal. So this okay. Pressure is a scalar. Area depends on the context. Okay, if you take it as a vector quantity, generally you talk about the scalar. But when you write it in terms of cross Go. Okay. Sorry, miss. Shall we proceed? Yeah. Listen. Now, when you talk about liquids, right? So liquids, when you speak in terms of liquids, there are two kinds of branches that I can speak about, especially fluids. There is something called as fluid statics and fluid dynamics, as the name suggests. Okay, what is fluid statics? If you are able to study the fluids which are under rest, you call them as fluid statics, right? So that is fluids at rest are called as fluid statics. Similarly, what are these called as? Fluids in motion. So when you have the fluids which are in motion, you call them as, we call that branch of physics as fluid dynamics. Okay. So first we will study about the fluids which are at rest. Right. So question is, when you start applying pressure to a particular liquid surface, then how does it get transmitted to other places? All those things we'll try to calculate. But did you guys understand what is pressure? So pressure is equal to thrust per unit area. So having this in mind, okay. Now, I'm going to talk about the next concept as pressure at depth. Okay. So, if I take the surface, okay, if I call this as the surface of liquid and there is liquid below the water. Okay. So here there are two words that we can use. One is altitude and the second is depth. Whenever you use the word altitude, it's always measured from the bottom towards the top. When you say depth from top, it is measured towards the bottom. So what we are going to do is, if this surface is exposed to atmosphere, then there will be an atmospheric pressure acting at this point, which is called as P0. So there is an atmospheric pressure acting at the top, and I am interested to calculate what is going to be the pressure, let's say, at a point A, which is at a depth H below. Okay. So listen to this. The next point I would like to define is, whenever you talk about the solid experiences force. Due to force, the object's mass will get accelerated. The object is going to get accelerated. Means, can I say that the mass is accelerated? In a similar way, when you talk about fluids, especially liquids, right? We don't use the word mass, rather we use the word density. Right. So we will take the liquid, means the main property on which we can concentrate is actually the density of the liquid, not the mass. We will not say, when a pressure is applied on a bucket of water, you will not say only this particular mass has got transferred. Rather, it is easy for us to speak in terms of density. So here, when I say density, I'm trying to talk about mass density. So how is density defined as? Volume density, volume mass density. So mass divided by unit volume is going to be the density. So what is going to be the SI unit for it? Kilogram divided by meter cube. Is the point clear? Okay. Now, what is going to be the CGS unit of it? Gram per centimeter cube, or it is also called as gram per cc, where that cc is also called as cubic centimeter. So cc is called as cubic centimeter. Is that point clear, guys? Here. Now see, for me to calculate the pressure at depth D, the first point I need to have in my mind is liquid is under static condition. Liquid is not moving, right? So for this, what I will do is, I will consider a cylindrical portion of liquid. Concentrate on this. So what is this? This is cylindrical portion of liquid. So if I consider the cylindrical portion of liquid, then if I draw a free body diagram for it, okay. Now, let me say the total depth is h. Okay. Now, instead of me labeling this point as A, I'll call it as some x. Reason I didn't want it as A because area will come. So I'll take this as x. And if I take this point to be y. Okay. So from the surface, a small change I'm doing in the diagram. From the surface, I am saying this depth is h1. And this depth is h2. That is, this h itself I've changed it to h2. Then what is going to be the length of the liquid column that I have considered? H2 minus. Is it clear? Now, there is a liquid, right, from the top of Y, which is exerting a force F1 in the downward direction. Am I right? Similarly, there is some portion of liquid which is from the bottom, which is applying a force in the upward direction, which is going to be F2. Okay, don't get confused. This is not pressure, this is force. And for the cylinder, there is going to be center of gravity from which the weight is going to act in the downward direction. Am I clear? So, under static condition, what can I say? Under static condition, F1 and W are in downward direction and F2 is in upward direction. So can I write F1 plus W is equal to F2? Here. Now, if I take the area of the top surface as A, then the area of the bottom surface will also be A. Is it clear? So what can I write? Since F1 plus W is equal to F2, can I write F1 minus F2 is equal to W? So what is force? Force is pressure into area. So pressure at point 1 multiplied with the area of cross section minus pressure of second area multiplied with the area of cross section is going to be equal to what is the weight of the liquid that is present? Density multiplied with volume into G. Density of whom? Density of that liquid. V is the volume of the liquid that is present inside the cylindrical portion into G, because it is mg. Am I clear? So P1 minus P2 into A will be equal to density is density only. What can I write the volume as? Can I write it as base area multiplied with the height into G? So what will get cancelled? A and A are wrong. So from this, what will I get? Listen to this carefully. P1 is equal to P2 plus rho GH, or P1 minus P2 is equal to rho GH. Is that not what you're getting? So what are we concluding from this? Pressure at point 1 is more compared to the pressure at point. Sorry, pressure at P1 minus P2. Actually, there is a mistake. How can it be? So it is F2 minus F. This will go to the other side. F2 minus F1 is, so P2 minus P1 into A is equal to this thing. So P2 minus P1. So I'll get P2 is equal to P1 plus rho GH, and P2 minus P1 is equal to GH. Because the pressure at the bottom is small. Okay, make a note of this. I'll explain this. What is the significance? Write it down. There is liquid at the below. There is liquid below X. So that liquid exerts a force in the upward direction. Downward direction. Because this is trying to push it down. What will the liquid be trying to do? Trying to push the surface. So what is this surface doing? It trying to balance. Or else what would have happened? If you want to balance the liquid, they would have gone like this. This would have gone up, this would have gone down for no reason. According to this, they should be balanced. You'll feel some, when you go into depth, you will feel a lot of pressure on you, right? Because there is more amount of liquid. That is the logic. Somebody is there, your hand, you're keeping your hand and keeping one brick on top of it. I keep 10 bricks on top of it. What it be there? Same logic. The same thing. Imagine them to be layers of solids. Okay. That's very far. So each, though the liquid is going to be kind of break it into layers so that you are able to visualize. So here there is one layer. At the bottom, 1, 2, 3, 4, 4 layers there. So those 4 layers are exerting a force on the fifth layer. The fifth layer is trying to balance. And the coins. I just took 2 points. I just took 2 points. So I need to measure the depth of X is H, depth of Y is H. So that Y can be anywhere. Got it? Understood. Got it? So P2 minus P1 is equal to rho GH, or P2 is equal to P1 plus rho GH. So P2 minus P1 is equal to rho GH. So if you see, P2 minus P1 is actually the difference in pressure. So this is actually called as GAU-GE pressure. So what is it? How do you pronounce it? Gauge or gauge, whatever it is. Okay. So that pressure, because there is the excess pressure, and this is the absolute value. Why did I say it's an absolute value? Because it is telling you the pressure at the exact point. So pressure at the exact point is equal to pressure at the topmost point plus density of the liquid into acceleration due to gravity multiplied with depth. Height கிடையாது, depth. Okay. So having said this, okay, there is a problem in this case. So there is a rectangular block like this, which has a base area. So rectangular block has base area A to be 25 centimeters square. It is submerged in water of density 1000 kilogram per meter cube. Find first pressure at 1, 2, P at 2. I'll tell you what those points are. And the second part of the question is force exerted by top surface and force exerted by bottom surface. So this is 1, this is 2, this is P1, this is 2, this is F1, this is. It's a very simple problem. Do it first. So what is the answer for 1? What is this depth? What is the first depth? How much is this? 0.05. So with that 0.05, calculate the pressure at that point. So pressure at point 1 is equal to how much? Density into G into H1. So density is how much? 10 power 3 into G is 10 into what is the value of H1? 5 into 10 power minus 2. So how much will you get the answer as? 5 into 10 power 2 Newton per meter square. That's it. Simple law. 5 into 10 power 2 Newton per meter square. What is going to be the pressure at 2? Use the same logic and tell me. By now you should have told. 0.05 is replaced with. Use the logic. You need to don't go with the formula. See, 0.05 is replaced with 0.07. So what will be the answer? Get now the 5 into 10 power 2. What will be the answer here? 7 into 10 power 2. Yeah, tell me. So what is going to be the force exerted by the top surface? It will be pressure at point 1 into A. So that is going to be 5 into 10 power 2 into what is going to be the area at the top? 25 centimeters square. So 25 into 10 power minus 4 meters square. So 5 into 25 is 125 into 10 power minus 2 meters square. That's the answer. So 125 into 10 power minus 2 meters square. Then what is the pressure at the bottom surface? P2 multiplied with area. What is the value of P2? 7 into 10 power 2 into 25 into 10 power minus 4. So answer will be 175 into 10 power minus 2, not meter square, sorry. Newton. You're also getting Newton. 175 into 10 power minus 2 or 1.75 Newton. Is the point clear? Okay. So next point is, or the next topic. Yeah, tell me. Your voice is.
Sir, can you explain why you, like how you calculated F1 and F2?
F1 is force pressure at point 1 multiplied with the area. So pressure at point 1 is 5 into 10 power 2. Into area they have given 25 centimeters square. So 1
Okay,
centimeter square is 10 power minus 4 meters square.
Okay, sir, I missed the conversion.
Okay. So shall we proceed to the next topic? So this is all about pressure at depth. Okay, the next topic is about Pascal's law. So it's very simple, right? So what does this Pascal's law speak of? So Pascal's law mainly speaks about the transmission of pressure. Okay, so it's not about the transmission of liquid, rather it is a transmission of pressure. Means how is pressure traveling from one place? Suppose, I'm not sure how many of you have observed, whenever there is a tire that is to be changed for a car, a bike it is simple. For a car, if they need to change the tire, what are they supposed to do? First is cut the connection of the tire with the ground. Have you ever seen that? Everybody has seen. What do they do? You have a car. So the tires are there. They need to cut the connection of the tires with the ground. So what do they need to do? They need to lift it. Right. So car is going to be in terms of few ton. That is in terms of few thousand kilograms. So it's not humanly possible for anybody to lift it manually. So obviously we need the help of some machine. So what do? They insert something and they keep stamping. They keep pumping it. Have you ever observed? So it's called as a car jack. So what that does is it will keep lifting the car so that the tire can come out easily. But how is it working? They are actually holding it in such a way that one part is in contact at the bottom of the car, the other part is in the air, which will be like a lever. When they press it here, how is it able to lift it on the other end? So what exactly is happening there is a question. So what is happening there? Their pressure is transmitted from one end to another. Am I right? Makes sense. So pressure is transmitted from one end to another. So that's what this Pascal's law mainly speaks about. Right. Thing is, if I'm able to design a system like this, where we have liquid inside, okay, and you have a piston connected. The piston is basically, you would have seen a syringe, right? At the end of it, you have it. So that is a piston. So when you have this connector, so that if you are able to exert a pressure here, right? If you're able to exert a force here, then if the liquid is incompressible, means it cannot be compressed, then what will happen to the liquid? So what is conserved? The volume of the liquid is conserved. So when you apply a force on one side, you cannot compress the liquid. So what will that liquid try to do? It will try to adjust its volume in such a way that on the other side, it will start pushing the other surface in the upward direction. Makes sense? Because it needs to get fixed in the particular volume. Whereas if it is a gas, what I can do is I can have gas here, or I can compress and I can hold it within my two palms also. I can do that because it is compressible. Whereas here, what I will make, it is incompressible. So volume needs to be there. So you apply force on one side and you take an output from the other side, so that you will be able to lift even heavy objects that are placed on the other side. Right? So this kind of transmission of pressure in an incompressible fluid is what is called as Pascal's law. So what does it mainly speak about? What does Pascal's law speak about? It says when you have an incompressible fluid, the pressure applied at one end gets transmitted to another end without any loss. So if I take the area of cross section here to be A1 and if I take the area of cross section here to be A2, then pressure at point 1 will be equal to pressure at point 2, which implies F1 divided by A1 will be equal to F2 divided by A2. So this is going to be the mathematical expression for Pascal's law. Whatever. lift up. When they want to repair it under the lift up. Speed is repair parts of the area. It will be equally distributed. It will be equally distributed. ஒரு இது இருக்கும் பேங்க் இருப்பாங்க பேங்க் வச்சுட்டு okay. So having said this, let's try out a problem. Done. So this is also called as a hydraulic lift that I do. Right. You have a hydraulic lift. Such a way that you apply a force of 50 Newton on the smaller side. On the other side, you have a load. Okay, load L, and it's a larger piston, and you have a liquid here, which is incompressible. Right. Now, a force of 50 Newton is exerted on piston X of area 0.025 meters square. And piston Y has an area of 0.50 meters square. So 0.5 meters square. Right. Calculate the pressure exerted on the liquid by piston X. So first, pressure exerted by piston X. Second, pressure exerted on piston Y. Third, force on Y. And fourth, maximum load that can be lifted if piston Y weighs 50 Newton. 9 days. Till where in a thermodynamics. You have any holiday? 2 days. Study at least important questions. Did they give you anything? Is there more problems or theory? Derivations. Derivations then should be easy. It's a very big lesson. Okay, what is the answer? Why are you doing the calculation? Very over. Yeah. 0.025. How will you write? First of all, I told you not to deal with convert into exponent. So how you write 25 into 10 power minus 3. So pressure at point X should be equal to pressure at point Y. Is that the first logic? So 15 divided by 25 into 10 power minus 3 is equal to what is the load? That is weight divided by 5 into 10 power minus 1. So this will cancel this 5 times. This goes 3 times. So what is the weight? Weight will be equal to 3 into 10 power 2. So it is 300 Newton. What did they ask? So pressure exerted by piston X. So first I can see that. So pressure exerted by piston X will be 15 divided by 25 into 10 power minus 3. This goes 3 times, this goes 5 times. So 3 by 5 into 10 power 3, which is 0.6 into 10 power 3 or 600 Pascal. 600 Pascal. That is 600. Similarly, what is the pressure on piston Y? You need not calculate it because that's what Pascal's law says. Whatever is the pressure at X will be equal to the pressure at Y. So 600. Right. So what about the force? Huh? Force on F1 euro, Fx euro. Pressure. So Fx already they have given. No? They are what are they asking? Force exerted on Y. So Y level of force. Then we calculated, no? 300 Newton. That is the weight. Right, 300 Newton. Now read the last question carefully. What is the maximum load that can be lifted if the piston Y already weighs 50 kilograms, 50 Newton? So logically speaking, when you are able to apply a force of 15 Newton, how much is the weight it is able to lift on the other side? In the side 15 Newton apply panna, what is the load getting lifted on the other side?
300 Newton.
So with 15 Newton, you are able to lift 300 Newton. Less effort, more output. That is one big advantage. That is one thing. Secondly, so 50 Newton can lift only 300 Newton. So what is the weight of the piston already? According to the fourth question, what is the weight of the piston?
50 Newton.
50 Newton. So 15 Newton, that is the 50 Newton applied on the thinner side, can lift only 300 Newton. Out of 300, how much is gone? Taken by the piston. 50 is taken. So what should be the extra load that I can add? What is the maximum load I can add so that it is able to lift?
250.
Sorry?
250.
That's right. Because in the first case, in the third case, what happened is we didn't take the piston to have any weight. So if the piston was considered to be weightless, then the weight that the 50 Newton could lift is 300 Newton. But now piston is also having some mass. So answer for the fourth one is going to be 250 Newton. Is the point clear? So does anyone have NCRT? There is one more problem. Those who have NCRT, you can go to page 256. I'll read this question. Write it down. Two syringes of different cross sections. Two syringes of different cross sections in bracket without needles. Without needles. Filled with water. Are connected with a tightly fitted rubber tube. Are connected tightly with a tightly fitted rubber tube filled with water. So the rubber tube is also filled with water. Now, diameters of the smaller piston and larger piston are 1 centimeter and 3 centimeter respectively. Diameters of smaller piston and larger piston are 1 centimeter and 3 centimeter respectively. Find the force exerted. On the larger piston. Find the force exerted on the larger piston when a force of 10 Newton is applied on the smaller piston. Second, if the smaller piston is pushed through 6 centimeter, how much does the larger piston move out? If the smaller piston is pushed through 6 centimeter, right? How much does the larger piston move out? How many of you solved it? First one you prepared. First is simple, no? So anybody who's online could solve the problem without looking at the textbook. So smaller piston, larger piston, right? Here the diameter is 1 centimeter. Here the diameter is 3 centimeter. So what will be the area? It will be pi d square. It will be pi d1 square by 4. And here it will be pi d2 square divided by 4. Am I right? So how much will this be? So pi by 4, or this will be 9 pi by 4. Correct? Now, what is going to be when a force of 10 Newton is applied? So F1 is equal to 10 Newton. Then what will be the value of F2? So F1 by A1 is equal to F2 by A2. So F1 by A1 are 10 divided by A1 is pi by 4 is equal to F2 is F2 only divided by A2 is 9 pi by 4. So pi by 4 and pi by 4 will get cancelled. F2 will be equal to 19 Newton. Means by applying 10 Newton on one side, you're able to generate 90 Newton on the other side. It is actually 9 times more effective. Next is, so how to do the next one? When you have a syringe like this connected with the help of a rubber tube, and you have a larger piston on the other side. Right. When you apply a force of 10 Newton here, what is the displacement taking place? 6 centimeter. So here what will happen on the other side is, this piston would have moved a distance of, I don't know how much value. Let me call it as x. Is it clear? So what is the value of x? If you think of the logic, you can do it in one step. Anybody? Sorry? Your voice is breaking a lot. You need to speak aloud.
So the volume of the cylinder is the same.
Yes. So if you read the question carefully, inside you have liquid and the rubber tube is also having liquid, means there is no compressible portion at all. So when there is no compressible portion, volume is said to be conserved. Okay. When volume is said to be conserved, then if I take the area here to be A1, and if I take this length as L1, and if I take the area here as A2 and this distance as x, so L1 into A1 will be equal to A2 into x. So L1 is how much? 6 into pi d square by 4 is pi by 4. If you observe one thing, I never converted the areas into the same, because both the side I have area, they'll get cancelled out. So I need not sit and convert it. Is equal to A2 is how much? 9 pi by 4 into x. So pi by 4 and pi by 4 will get cancelled. X will be equal to 6 by 9, which is in terms of centimeter. So 6 by 9 is going to be 2 by 3 or 0.67. Means the smaller piston moves to a distance of 6 centimeter, Whereas the larger piston moves only through a distance of less than a centimeter, which is 0.67 centimeter. Is that point clear? Right, make a note of it. Because liquid is incompressible. See, whatever is the volume that got covered should be equal to the volume that has got displaced here. So what is the formula for volume? Base area into thickness. So area of the piston is known into the distance is the thickness. In centimeter is the move set. So dotted lines are the new position. Done? Okay. See, as I told you in the beginning of the chapter, fluid statics consists of these two laws. And there are two simple applications. One is called as a barometer and the second is called as a manometer. You have heard these terms? Barometer is a device, bar is another unit of pressure. So barometer is a device which is used to measure the pressure. Okay, manometer is also used for the same, but manometer mainly measures the pressure difference. Okay, so those applications I'll explain tomorrow, and I'll start with this part, the fluid dynamics. Okay, you guys asked me for a topic, and what topic was it? Only Poisson's ratio. So that part I'm going to teach. See, those who are online, I hope you could understand, right?
Yes.
Okay. Yeah. See, there was one concept left out from the previous chapter, which is called as Poisson's ratio, but I'll explain now. See, logic is very simple. When we discussed about the longitudinal stress, when you have a wire, okay, when you have a wire, so the wire has a cross-sectional area, right? So when it has a cross-sectional area, can I say that area is formed due to the diameter of it? It has a thickness associated. So let me say the thickness of that wire is D and the original length of the wire is L. Okay. Now you suspend some weight. What did we discuss about according to the longitudinal stress? that the wire will undergo some elongation, right? So the actual concept that we learned is something like this. This is delta L. So how did we write the Young's modulus as F divided by A divided by delta L by L? So here, if you observe one important point, we need to understand that you're using the same amount of material. So that material is only getting elongated. Then what else is the other parameter actually supposed to change? When the length is increasing, actually the diameter should decrease. Means if I draw the diagram, it should look something like this. Okay, there is a decrease in the diameter. If I say the change in the diameter is delta D and the original diameter is D, if I say the change in length is delta L and the original length is L. Okay. So what does strain tell us? Strain says change in dimension to the original dimension. So diameter is also a dimension, length is also a dimension. So change in diameter to the original diameter, I need to call it as a strain. I have not yet given a name to it. Similarly, delta L by L, this also I'll call it as strain. No name given to it. Now we need to set the prefixes. So if you see, diameter has to do something with the sides. So sides of a shape are generally called as lateral. Length has something to do with the longitudinal aspect. So change in length by original length is called as longitudinal. Now the question is there a possibility where I take the ratio of only the strains that are there on the material? Yes, I can do that. Delta D by D divided by delta L by L, both are an effect. You know what is the meaning of effect? Effect is something that you're able to see because of you adding the load. But the only point is here delta D by D will be negative because the diameter is decreasing. Right? So if I am able to write this delta D into capital L divided by D into delta L, then this ratio is called as Poisson's ratio, and it is generally represented by this sigma. I hope you could understand that. You need not memorize the terms. Lateral and the longitudinal. When you sit in exam, all it can confuse you, but I hope you understood the logic. Lateral is sides, longitudinal is length. Long and vertical, that is length. This is because a cylinder's projection on a two-dimensional is a rectangle. Cylinder is three-dimensional. When you place a cylinder and you look at it straight, it looks like a rectangle because you cannot see the curvature. You will only see the sides. Here it is. Okay. Length is increasing, diameter is decreasing. The adjustment will happen in such a way that the total volume is constant. Because you have same amount of material. Volume should be the same. Volume above the different are. Volume will become different only when you use a part of it. If I the bender, imagine this as a flexible object. When I bend it, it will take the shape of a curvature. But what is going to be the volume of it? It's still the same because it's the same amount of material. When you release it, what will happen? It should come back to the same shape, right? So that's what is happening. Hydrostatic, because you are talking about perpendicular force. That is why when I spoke about pressure, I related to perpendicular. There we use the word perpendicular force. Here it is called as thrust. Actually, in fluid statics, I forgot you have this buoyancy and arcing distance. So I have to teach that. Then only I can go to the dynamic part. Negative will clear the not necessary. Negative diameter decrease. Okay.
Sir,
Sorry.
so because del D by D is negative, Poisson's ratio will always have negative value.
Yeah, you can say that. But generally, we don't write it as negative value. We'll write it as positive only. But minus sign is only the indication of decrease. Okay.
Okay, sir.
சொல்லுமா எப்படி சொல்றேன் yeah directly again directly proportional சொன்னாங்கன்னா when this is changing, that is also changing the context a little bit. Okay, so because we never discussed about that part in the Young's modulus, I should have actually, when we speak about this is what is supposed to happen. But when we solve problems, we never took the decreased area, we took only the original area. So what they mean by directly proportional is not mathematical. They both are related.
Sir, if we take the Poisson's ratio for compression, then del L by L will be negative.
It
So
should be,
still
but
Poisson.
generally for wire, you will not take like that. This is again applicable for these wires and all, right? You generally don't do the compression part. What does that mean?
Okay, but sir, is there any case where Poisson's ratio will be positive?
It cannot be. No, see, one is decreasing, the other has to increase. That's what is supposed to happen. There is no possibility of such sort.
Okay, sir.
That is what the effect is saying. No, you're able to see. Right. See,
Yeah,
listen.
sir. Okay.
So next class, remember the topics, okay? The order that I'm going to deal with. One is barometer. Barometer is an application of pressure varying with respect to depth. Next is manometer. Okay, that will help you to measure the pressure difference. Okay, one will give you the absolute value, second will give you the pressure difference. After that, only fluid statics over. Next part is about what will happen when you take a solid and immerse it into a liquid. That is when the buoyant force comes into picture. Okay, buoyant force, or you call it as upthrust, based on which I'll explain you the Archimedes principle and we'll do some problems based on it. After that, I will go to the dynamic. Okay. See, viscosity and surface tension are slightly larger concepts. Like they take a lot of time. I'm not sure if I can finish it before 12. Okay, I don't want to rush off at the same time. It'll be of no use. So I think, like how you guys have asked, I've already given the thermal properties of matter and thermodynamics recordings. If you want, you can go through them. It's broken according to subtopic only, but those are all actually not a pre-recorded by me. Those are all the class recordings. But here and there, you'll be able to hear someone speaking. That will also help you. Okay. I think thermodynamics, certain derivations alone I spoke it, voice cut பண்ணிட்டேன். But other things will have it so that will help you for the exam point. நான் சொல்லி தரப்ப make sure you. So no unique. Yeah, I've already given. She asked me last week. I already gave it. Pre-recorded videos.
Sir, I have physics exam on 5th. And
Okay.
would it be possible if, like, can you
Yeah,
give
you
me a
asked me some
video about,
topics. You asked me some
yeah,
topics. Viscosity and
viscosity, surface energy and tension,
okay.
and angle of contact, Bernoulli's theorem?
Okay. I'll try. I'll try to do it by today or tomorrow. Maximum, I'll try to give it by Saturday, okay, so that you can revise. Other topics you try to concentrate.
Okay, sir. Thank you.
Yeah. See, 1 minute, don't leave, okay? See, you're able to see here, no, in the app, you'll not have web access, this is admin access, another is the So videos, if you go, there is this pre-recorded part. So in the pre-recorded, I've given thermal properties of matter and you have thermodynamics also. Is online class recording. So paranga, but I think I have recorded them separately also. And our roti 30 path, if they are there, I'll add it. Thermodynamics, I remember recording separately. Each derivation on the record panna. I'll just go through and see. Okay. So this will help you for the time being. But when I come to those topics, I'll give you in detail. Complete. அதில் ஏதாவது உங்களுக்கு புரியல ஏதாவது டவுட் இருக்குன்னா ரீச் அவுட். இது ஆங்கிள் ஆஃப் கான்டாக்ட் என்ன கேட்டேன்? தேங்க்யூ. Okay. So like this, see, this is what I told you. Actually, I have some recording which I've done separately also. Yeah. பண்ணி கொடுக்குறேன், அது problem. Right. Relative velocity deleted நான் சொல்லி கொடுத்தேன். 2 dimension. I taught you relative. நீ சொல்ற the rain umbrella problem. We did some problems also. Yes. We did. 2 dimension தான் நான் பண்ணேன். 1 dimension I did. That monkey running on a train and all I did. இருக்குன்னு நினைக்கிறேன் already பாருங்க. Okay, in spite of if you don't have, no problem. You let me know those topics, I do and get. So இது வந்து, yeah, this. So இங்க topic wise இருக்குல்ல, I think this will help you. Right. Anything else? So that's it from my side, guys. We can wind up.
Thank you, sir.
Yeah.
Thank you, sir.